Hi, I'm Mr. Huber, and in this video I would like to talk about problem 7a. So that's the function f of x is equal to x minus 4 squared plus 3. Now look, I first do it without a table, and then in order to check, I'm going to work out a few numbers in the table. Look, this one is a horizontal translation 4 units to the right, and everything will go up by 3 units. Now, look, 4 to the right and 3 up. That will be my vertex. So the vertex, this is why it's called the vertex form. Vertex is V, 4, 3. And from there on, because we have a 1 here, it's 1 to the right, 1 up, 2 to the right, 4 up, 1 to the left, 1 up, 2 to the left, 4 up, and I could even go 3 to the right and 9 up, and 3 to the left and 9 up. Okay? This is a very exact drawing. It's more than a sketch. Okay? Now look, let's try if this is right. So this is the vertex, V, the lowest point, the minimum, 4, 3. 4 to the right and 3 up. So let's see. Apparently we need to start at 4. Okay, let's do that. 4, 5, 6, 7, and 3, 2, 1. So let's plug in 4. F of 4, well, that's 4 minus 4 squared plus 3. So it's just 3. You see, this is the lowest possible value this can take on. It's 0. And that only happens if you plug in 4. So it will be 3. At 4, it will be 3. Let's try 5. 5 minus 4 squared plus 3. So this is 1 plus 3. It's 4. So at 5, it will be 4. F of 6. 6 minus 4 squared plus 3. So this is 2 squared, so it will be 4 plus 3, it's 7. You see? It checks out. Let's do, for example, 2, f of 2. So it's 4 minus 2 squared. No, 2 minus 4 squared, I'm sorry. 2 minus 4 squared plus 3, and that is equal to minus 2 squared plus 3. So it's 4 plus 3, it's 7 as well. Here, 7. You see, at 2, it goes through to 7. Here we go. Clearly, you don't have to fill in this table because you know the pattern now. It will be shifted to the right and 4 up. And sometimes, if it's a vertical stretch or shrink, we just do something like this. Let's just fill in this quickly. This will be 12, this will be 4, and this will be 12. Well, sometimes when you are asked to do something like this, so let's say you're asked to sketch this graph, what you do, you have a system of coordinates, then you do 1, 2, 3, 1, 2, 3, 4, and it will look somewhat like this. Okay, this is a quick hand sketch. Okay, you don't have to draw it as exact as this each and every time. For the moment we do, but later on you say, well, it's approximately something like this. And please keep one thing in mind. If you draw it like this, you could think that it never crosses the y-axis. But every quadratic crosses the y-axis because you could plug in 0. Look, if you plug in 0, f of 0, so what happens at 0? Does it go through the y-axis? Well, let's try. 0 minus 4 squared plus 3. So it's minus 4 squared, it's 16 plus 3. So it will be 19. Well, it would be 18, 19, so it would go through here. You see? So every function will eventually cross the y-axis. So if I had to draw this one, I could also do it like this and say, well, this is 3, this is 4, and it will go through the y-axis. Don't make a V shape, try to make a rounded parabola, and you know this will be 19, okay? It will cross the y-axis at 19 because you could plug in 0 here. Well, we did it in a more exact way here, but you see it's clearly not necessary. It's clearly not necessary to calculate the table anymore, which is a good thing. You know it's a horizontal translation by 4 units to the right and a vertical translation by 3 units up, okay? So I hope it wasn't too difficult. See you on the next one.